Okay, so now we're going to look at part B. For part A, we worked out that the acceleration, which is given to us in the question anyway, is 0.75 meters per second squared. Okay, right. Part B, find the magnitude of the tension in the bar. Now, if I looked at the whole system, as we discussed a second ago, it wouldn't help me because the tension in the bar, when I resolve the forces for the whole system, would go. So I need to consider just either the car or the trailer. What I'm going to show to you now is it doesn't matter which one we use. So let's just look at the car. Let's just look at the car. So the car. Then I'm going to resolve in the horizontal direction. Right, let's just look at the forces acting on the car. So whenever I do that, I draw a real careful line. Yeah. So let's just draw this line. These are the forces acting on the car. Right, just these forces. That T applies to that bit, that friction applies to that bit there, that resistance to motion, apologies. Yeah, so let's just look at this. Now I'm just going to resolve this. Okay, so we've got, calling that the positive direction, I've got 1,200. What's acting against it? Well, both 200 and T is also acting in that direction, isn't it? So minus T. This is the resultant force, the F, yeah, the F. So F, this is the resultant force, is equal to mass. If I'm looking at the car, it's just the mass, which is 900, times the acceleration, which I worked out a second ago, 0.75. All we need to do now, T over here, this over here, and you should have got that T was equal to 325 Newton. So this, I don't know why this question is worth 3 marks if I'm honest, because it's actually more straightforward than part A. Now, what I want to show you is it didn't matter whether I use the car or the trailer. So let's just double check and see if it works for the trailer. Trailer. Again, I'm going to resolve in the horizontal direction. So I want the mass, the resultant force, sorry, not the mass, the resultant force, and then I'm going to equate that to mass times acceleration. So the forces, just the forces acting on that one, let's do it in a dashed line so it's a bit nicer. Just the forces acting on this bit here. Well, I've only got T going in this direction because that 1,200 was applying to the car, wasn't it? So the only thing actually acting on the trailer is T is the thing going in that direction. What's acting against it is just 100 is equal. And because I'm just looking at the trailer, I'm only looking at the mass of the trailer, which is 300, times the acceleration, which I worked out to be 0.75. When I rearrange that, so I add that onto both sides, that's just going to give me T, again, equals 325 newtons. In fact, this time, it's probably easier to do the trailer because there's less steps involved. But it's also a good check for you, just to make sure, because the tension should be the same for the trailer as it is for the car. So I'll be checking both ways. And if they're not the same, then I know I've made a mistake. Okay, right, that's part B. Moving on to part C, which is the main bit I know that people found confusing.